Okay, lads, this is Monday, the 11th of May. I hope all is well with you. And I've already sent you a copy of the 2016 higher level exam plus the 2016 solutions. And I'm just going to go through the solutions here with you now. So, this first one is an orthographic projection. Okay, elevation, plan, and end view. We were fairly good at those, we're not too bad anyway. So let's just start off with our dimensions. You have the dimensions. We started by boxing in the elevation and boxing in the plan to the dimensions given. Okay, you can see I added the two little curves here and here. You have the dimensions in front of you, so I'm not going to call them out. There's our semicircle. Note that we're working on the plan. The reason we're working on the plan is because it's easier to get dimensions on the plan in this instance only, and we can transfer it up to the elevation. So you can see the plan is coming fairly well together here, and I've drawn it like that. Now I didn't put in the sloping one, I'll have to get that from the end view. We'll see that later on. Anyway, we can start building up the dimensions for the elevation. Taking up those dimensions, and I'm going to snap through it as best we can. Sloping dimensions. Now you can see that we have nearly all of the elevation drawn. A few dotted lines to be added in here, just showing the slot there, like that. And so, use the given measures to outline the elevation plan. The cylindrical holder in elevation and the speaker in plan cannot be completed if the end view is shown. And we always have that in these questions. So I'm going to start drawing the end elevation here. Bring my lines over. Like that, that's 45 degrees, project it up. The heights are going to be the same on the end elevation. The width I project off the plan, and bear in mind you have the solution. I've given you the solution, I've given you the question and the solution. Bring these lines across to put them in the elevation and plan. You can see that it just goes a little bit short of that. And finally, some key dimensions here. Where that hits the sloping surface, I can only see that on the end view, so I bring it down here and across. And that gives me that line. So I can bring that line in there, because this face here is sloping. I can go about 10 mils and draw in a little window there on the end view. I can bring that across to the elevation, those two little green lines there. And of course, now I can bring them down to the plan. Like that, and that gives me that, and that's my elevation, plan, and end view. Okay, so to get this parabolic shape here, well, it's always handy to divide that into 30, 60, 90, 120, 160, 180, divide that into 6 divisions and bring them up. If you use just 45s, it will work the same. So I'll need to bring those lines up here to find the width, bring these lines over here and up here to get the end view. And we're going to see that. So those two lines, I found that there. Those 2 points I found here. When I say two, that and that because they're in line, that and that because they're in line, I can bring those over to the elevation. Up from the plan here, that is up from the plan. That was brought over here to the end view. So I have those. And finally those two. And there's my method. Now, the final bit, as I said to you, I wouldn't be worried about this, but we can just draw it. And we're just going to rotate that around, bring it up to the elevation, gives me my true shape, and that's that. Okay. Here's my elevation, my plan, my end view, question 1. Okay. Now, I'm not going to bother with question 2, so I'm just going to fly through here for a moment. So, I'm actually not even going to comment through this one, but I'm just going to go through it so that if you want to see it. Various points of contact, drawing the gate. I'm going to take my time here. Or not even going to take my time, I'm going to rush through it. But I'll just I'm including it in if you want to try it there. I'm enlarging that little polar enlargement. As I said, it's not a question I did with you, it's not a question I want you to do, so I'm just going to fly through it here. I used to do this question when still adds, but it became a couple of years ago, but it became a little bit more complicated. It was a lot harder in the past 3 years, so I just stopped doing it. But it's here anyway if you want to give it a try, and so I'm just going to go through it really quickly here, like that, and there's the double, right? And bringing these points over from my little pentagonal shape, it's this view when it's tilted at 45 degrees. And that gives me that. So I'm going to rush through the final points, and that'll be it. But I said there's a lot in this. It was a lovely question for a couple of years. We just kept adding and adding and adding to it, and eventually I just said to hell with it. I'm not doing this one anymore. So this recording here, and we're going to take a look at the isometric scale. 30 degrees, 45 degrees. True length, isometric length. Mark off the main dimensions. 90, 50. As you can see, it's going to be an S, as always, and 100. And box it in. For scale, we have that. Our next dimensions are 20, and we'll add that in, and put that in. Now remember, only these scaled isometric dimensions do we use. So I'm going to draw in the box. So I always say draw the straight line elements first. Avoid the curves, just get these out of the way. It's nice, these are usually nice and easy. You know what our dimensions are. All put on the scale here. Bring it down. This little construction here will help us with the handle of the elevation. Okay, it'll give us that. I can take those dimensions, mark it off there, and draw it in. That little construction is very, very handy. And there's most of the straight line elements drawn now, and that gives us the center. Now I didn't heavy in that yet, and I will in a moment, but you'll see why. So I'm drawing this box layout here for the lamp itself, the main part of the lamp. So we know I've shown you a couple of methods drawing your circle and isometric. Here's one, you can go 10, 10, 5, 5. I just want to locate these lines here. I need to do the same thing, 10, 10, 5, 5. Here, 10, 10, 5, 10, 10, 5. Take those heights, mark them off in the elevation here. 1, 2, 1, 2. See where I get the arrows? Next one, that one, it's there, there. And finally, these last ones. Now, you don't need to get it. You can use the little method I've given you. You get less points. It's easier, but probably doesn't look as nice, but it still works. So I'm going to get these, mark them in, like this, and draw these in here, just that, and finally, I can just draw this final one in here. That's a smaller one. In exam sets, it's hard to get this done in half an hour, but let's just draw it anyway, and you can see the myriad of construction lines. I'd be kind of estimating it at this point. You're not going to lose, once you've shown how to draw one circle, you're not going to lose a huge amount of marks drawing this one. So we got that. So remember, start our scale, start by boxing it in, work from there. There's our isometric scale. Okay, 45 degrees, 30 degrees. True dimensions on here, bring them down to isometric lengths. They're the lengths we use on our isometric drawing, and that's it. So, next one is the one I like. It's the one that we just started really. It's a nice easy question, which is our development question. This is made of a truncated cone, truncated cylinder, and another truncated cylinder up here. So, draw the elevation, draw the plan, draw the end view. Okay, so the sloping surface is the one that we're going to need to do. So if we divide it into 30, 60, 90, 120, 150, 180, 12 divisions, bring them up here, bring them across, it will give us that nice little dimension there. Right? Now I often draw these separate when I'm doing them. Okay, So we want to draw our cone. So if I extend this surface up here, extend that one, that will give me the apex of the cone that would have been there. Okay? And I'll use that length to draw my cone. So you can see, take that length, by extending it up, it gives me the length of the cone, and mark that off. You're familiar with this. Divide this into 6 divisions. 6 because it's only half. Take one of those, same as that, same as that, same as that, same as that. Divide it off into 6, like this. We have that. And, that's the development of a truncated cone. Here's the development of a truncated cylinder. Where am I getting those little dimensions from down here? That's a little arrow. There you have it. And I'll draw that in. And that gives me that. Okay. There we have it. Nice. Okay, finally. Well, finally we'll do this third exercise. Then I'm going to take a look at this. And this, of course, is my transformation geometry. Question, right? Or translation. Move everything up. This P1, P to P1. Everything moves up the same distance. You bring up the points. Like that. And draw it in. That just moves up there. Okay. Axisymmetry. Mirror image. P1 to P2. P2 is the image of P1 under a mirror image. So we want to bisect that line. Draw our mirror. That's our mirror. Okay. Perpendicular lines here. That gives me B. Once I have that drawn, I can just hurry and now draw the rest. And that's my mirror image. Here is my axis of symmetry. Central symmetry, image in a point. P3 is the image of P2 in a point. So I'm going to find the point. So P2 is the image of P3 is the image of P2 in a point. So the point we know is going to be halfway. Don't need to bisect it, you can measure it. There's C. Everything goes through C out the other side. There's A. That distance is the same as that distance. To find B, through C out the other side, take that distance, mark it off. There's B, and I think it's really handy to draw that last portion. Now, finally, clockwise rotation through 90 degrees. Before is the image of tree through clockwise rotation. Clockwise is this way, lads. Rotation 90 degrees, so we only need our point of that. So 45 and 45 adds 90. That leaves 90 here. So here's a point of symmetry. And I'm going to draw that in there. Everything rotates around that point there. I'm not going to get too hung up in this one because I haven't done it with it. And there's our transformation geometry. So the only one left, lads, is the ellipse, and I'm just going to fly through that. You have to, because we've done this one so many times. Drawing our line, finding the major and minor axis. Use that standard ellipse construction. It gives us our ellipse. Okay, so I'm going to get our tangent to a point outside the ellipse. You need to find your focal points. Okay, draw your curve from P1. Take your major axis from F2. Bring it back, and that gives you a point of contact and your tangent. Here's our parabola. You have to draw a parabola, lads. God knows we drew it enough times. I think we're okay on that. I'm just using an axial symmetry there to draw that. And I'm going to fly through the rest of it using the arcs here. Now we're a little piggy bank. Now you're drawing your parabola, you're drawing your ellipse. Major part of the question is drawn, and that's it. Okay, lads. Thank you.